Every time your phone connects to the internet, every video you stream, every message you send, every map you load while walking down a street in Addis Ababa, that connection begins at a single physical point. A tower, an antenna, a piece of hardware standing on a rooftop or a hillside that your phone found, locked onto, and started talking to in milliseconds automatically, without you doing a single thing. But here is the question almost nobody asks. What is that tower actually doing? And why did the engineers who built 3G networks call it one name, then completely redesign it for 4G and give it a different name entirely? Welcome back to Technology in a Minute. Today we are answering one question that sits at the heart of how every modern mobile network actually works. What are eNode-B and eNode-B, and why does understanding the difference between them explain everything about why your 4G internet is so much faster, smarter, and more reliable than the 3G network that came before it? Here is why this matters right now. 2 episodes ago we talked about the BSC and the RNC, the controllers that sat above the towers into G and 3G networks, making the big decisions about how connections were managed. Think of those controllers as the headquarters, and the towers as the branch offices that simply followed orders. eNode-B was the 3G branch office. It did what it was told. eNode-B, the 4G tower, is something fundamentally different. It is not a branch office anymore. It is a fully autonomous decision maker. The headquarters was dissolved. The intelligence moved into the tower itself. That shift, from a dumb antenna following instructions to a smart tower making its own decisions, is one of the most consequential architectural changes in the history of wireless communication. And by the end of this episode, you will understand exactly what changed, why it changed, and what it means for the networks being built in Ethiopia and across Africa right now. Let's start with eNode-B, the 3G tower, because understanding what it was designed to do makes the leap to eNode-B much clearer. eNode-B is the name given to the base station, the physical transmission tower, in a 3G UMTS network. UMTS stands for Universal Mobile Telecommunications System, which defined how 3G networks were built globally. When your phone connected to a 3G network, it was connecting to eNode-B. That tower's job was straightforward. Transmit radio signals to phones, receive signals back, and pass everything up to the RNC for processing and decision-making. Here is the key thing to understand about eNode-B. It was deliberately kept simple. Think of it like a very sophisticated microphone and speaker system. It converted digital data into radio waves going out, and converted radio waves back into digital data coming in. That was essentially its entire job. Every intelligent decision, which frequency to use, how much power to transmit, when to hand a call over, all happened at the RNC. The RNC sat somewhere else in the network, connected to eNode-B by a cable or fiber link. Tower equals simple transmitter only. Round trip delay, 50 to 100 milliseconds per decision. Fine for voice, fatal bottleneck for smartphone data. In the late 1990s, centralized intelligence made sense. Computing power was expensive. Putting a processor in every tower would have cost a fortune. The IAB interface introduced a round-trip delay of 50 to 100 milliseconds. Every time your phone needed a decision, the request had to travel. For streaming video or apps requiring rapid data exchange, it was a serious bottleneck that no amount of towers could fix. eNode-B was designed for the network it was built for, but the explosion of smartphone data exposed a fundamental limitation. Stay with me here, because this is where eNode-B changes everything. eNode-B, the E stands for evolved, is the base station of a 4G LTE network. It is a fundamental redesign. The single most important thing to understand about eNode-B is this: the RNC is gone, completely. All of the intelligence that previously lived in the RNC has been moved directly into the eNode-B itself. Every tower in a 4G network is now its own decision maker, managing frequencies, power levels, and communicating via the X2 interface. In eNode-B architecture, tower equals full intelligence on board. RNC eliminated. Round-trip delay, under 10 milliseconds. In the 3G world, eNode-B was a soldier waiting for orders. In the 4G world, eNode-B is a fully trained commander. Performance jump. 3G latency was 50 to 100 milliseconds. 4G latency is under 10 milliseconds. 10x faster, 10x more responsive. Because eNode-B handles decisions locally, the network can also handle dramatically more simultaneous users for the smartphone era. eNode-B did not just make mobile internet faster, It fundamentally redistributed intelligence to make speed, reliability, and scale possible. Now let's talk about what the shift from eNode-B to eNode-B actually meant for real people. Because the architectural story is fascinating, but the human story is where it becomes genuinely important. Start with what 3G connectivity, built on eNode-B towers, actually delivered to Africa when it arrived. For hundreds of millions across the continent, 3G was not just a faster connection. It was the first internet connection they had ever had. Not an upgrade from broadband. Not a supplement to home Wi-Fi. The first time they could access the global internet or send an email. World Bank data shows mobile phone penetration in sub-Saharan Africa grew from 2% to over 60% between 2000 and 2012. That growth was powered almost entirely by the eNode-B tower rollout. A 10% increase in mobile broadband equals 1.38% GDP growth. Every eNode-B tower that went up on a hillside in rural Ethiopia was not just equipment. It was an economic development intervention. Then eNode-B arrived, and the impact compounded. Ethiopia's rollout of 4G LTE brought a qualitatively different kind of connectivity. Not just faster speeds, but applications that 3G's latency made impossible. Video calls that actually worked and mobile banking platforms. Telemedicine services connecting rural health posts to specialists. E-learning platforms delivering content to students without physical libraries. The difference between eNode-B and eNode-B was the difference between reading text and participating fully in the digital economy. And here's the secret: eNode-B towers do not just communicate with phones. They communicate with each other via the X2 interface. When your phone moves between towers, they talk directly to coordinate the handover. The receiving tower knows you are coming before you arrive. The result is seamless mobility, moving through a city without ever feeling a disruption in your connection. The eNode-B towers along your route are passing your connection like a relay team passes a baton smoothly, quickly, without dropping it. Now here is where we have to be honest, because this architecture has real limitations that the industry is working to solve. Limitation 1. The coverage gap. eNode-B towers are expensive. Rural Ethiopia still relies heavily on older 3G or 2G infrastructure. In urban Addis Ababa, 4G has expanded. But where population density is low, the economics are harder to justify. Closing this gap is difficult. Limitation 2. The backhaul bottleneck. A fast tower connected to slow backhaul infrastructure delivers slow speeds. Backhaul requires fiber optic cables or microwave links. In areas where this is limited, even the most sophisticated eNode-B cannot perform. Limitation 3. Energy demand. eNode-B towers consume more power than simpler eNode-B stations because of their processing capability. In areas with unreliable electricity, powering these towers requires diesel generators or solar installations, adding cost and complexity. These are not insurmountable problems. They are the honest engineering challenges that every country building a modern network faces. Understanding them allows us to address them intelligently, ensuring technology continues to drive Ethiopia's socio-economic evolution. So zoom out for a second. What does understanding eNode-B and eNode-B actually mean for Ethiopia, for Africa, and for the networks being built right now? Here is the bigger picture that ties everything together. The shift from eNode-B to eNode-B was not just a technical upgrade in the traditional sense. It wasn't just where one generation of equipment gets replaced by a slightly better version. It was a philosophical shift in how networks are designed. The 3G philosophy said, put intelligence at the center, keep the edges simple. The 4G philosophy said, put intelligence at the edges, let the center coordinate rather than control. That shift, from centralized to distributed intelligence, is happening across the entire technology landscape right now. In cloud computing, the LTE base station, a redesigned tower that absorbed all that intelligence into itself and eliminated the central controller. It reduced latency to under 10 milliseconds, delivered speeds 10 times faster, and enabled towers to coordinate through the X2 interface. The shift between them is the shift from a soldier waiting for orders to a commander making decisions. And that shift changed what mobile internet could do for hundreds of millions of people across Africa. You now understand not just what these hardware are, but why they were designed the way they were, and where the architecture is going next. That is a complete picture of the physical infrastructure your digital life runs on. If that is the kind of understanding that matters to you, subscribe and turn on the notification bell. Every week we take one piece of technology shaping your world and make it this clear. Join the community of people who stay informed. Next episode, we go inside 5G and eNode-B and ask the question, if 4G feels fast enough, what is 5G actually for? And who does it really benefit? See you there.